Welcome to Ratio Review Part 1. This is a work-along assignment. Make sure that you have your version of this pulled up as a PDF, or at the very least that you have some paper and pencil handy, or better yet, hopefully you have already worked along and already have your answers ready. So first of all, we have this example table up here that is giving us the situation, telling us that a school store is selling headbands for $2 each, t-shirts for $8 each. They wanted them to write ordered pairs to compare the costs, and then they wanted us to make a table for that value. Now, it says that the cost of headbands follows the rule of add 2, 0, 2, 4, 6, 8, 10, and that's represented in the table. T-shirts follows the rule of add 8, and that's represented also in the table. It then wants you to write corresponding terms as ordered pairs. A corresponding term is something that showed up in algebra much later in our year, but those are numbers that are in the same place in two or more related patterns. So this could just be as simple as they both started at 0, 0, and each one of them kind of corresponds to each other. The first number is connected to the second number in some way. Now, for our actual problems, it wanted us to answer the question, use the rule add 8 to find the cost of 6 t-shirts. Well, if we're just adding 8, we can do, this is 0, 1, 2, 3, 4, that's 5 shirts. So the 6th shirt is just going to be 8 more. Add 8, and it's going to be 48 for 6 shirts. So we added 8 to 40. That's our explanation. Number 2, it says for each ordered pair in the table, how does the second number compare to the first number? So we have 8 compared to 2, 16 compared to 4, 24 compared to 6, 32 compared to 8, and 40 compared to 10. The connection is most obvious right here. 40 is exactly 4 times as much as 10. 32 is 4 times as much as 8. 24 is 4 times as much as 6. The second number is 4 times as big or as large. And an ordered pair, all that is it's a pair of numbers that we could locate on a coordinate plane. That's all that those are. Number 3, if the cost of headbands is $20, what will be the cost of the t-shirts? Well, we just said the second number, which is the cost of my t-shirts, is going to be 4 times as much. We just start doing that first number times 4 for every single part. So down here, if headbands cost $20, all we have to do is multiply that by 4 to get our answer. 20 times 4 gives me a cost of $80. That should be my answer for number 3. For number 4, one pattern starts at 0 and follows the rule add 2. Another pattern starts at 0 and follows the rule add 5. Write the first 6 numbers in each pattern. How did the terms in the first pattern compare to the corresponding terms of the second pattern? Well, let's see. We'll go ahead and draw a little table. So we have pattern 1 and pattern 2. So they both will start off at 0. So they both start at 0, and pattern 1 is going to follow the rule of add 2. So 2, 4, 6, 8, 10, 1, 2, 3, 4, 5, 6. So yep, that's the first 6. And pattern 2 follows the rule of add 5. So 5, 10, 15, 20, 25, and it keeps going. And then it asks, how do the terms from the first pattern compare to the corresponding terms of the second pattern? Well, you can't just say, oh, it's 3 less, and then it's 6 less, and then it's 9 less. It needs to be one concise word. So here's a little tip. Ratios came from a calculator active unit. What you can do is you can take that second number and divide it by the first number. And that tells me that my second number is 2.5 times bigger than my first number. Or I could say that my first number is 2.5 times smaller than my second number. So I did 5 divided by 2, and that got me 2.5. And my answer for this one, that's my work right there, is I'm going to write that the first number is 2.5 times smaller than my second number. And that's it. For number 5, it wants us to complete this table down below. It gives us an x, a y, and it asks for ordered pairs. We'll start by doing my x's. The x is following a pattern. 0, 6, 12, they're counting by 6's. We're just adding 6 to each one. 12 plus 6, 18 plus 6, and 24 plus 6. Then, this table, which is following a pattern of add 3, again, you really should have worked ahead already, and only be reviewing this if you need help if you haven't done this, and then pausing and moving on to a problem that you do not need help with. This is going to be 6 and 3. This one is 12 and 6. This one is 18 and 9. This one is 24 and 12. And then finally 30 and 15. Describe how the relationship between the corresponding terms. Well, it looks like the second number is always half of the first number. So the second number is half of the first number. One thing that also could have worked is I could have explained it as saying that I get the second number by dividing the first number by 2. Different explanation, but same answer. For number 6, a shop sells matching hats and scarves. The scarves cost 1.5 times as much as the hats. Write 2 patterns that could represent the cost of 1, 2, 3, 4, and 5 hats and scarves. Okay? Well, let's see. So we've got hats, and we've got scarves. I think we can assume that 0 hats, 0 scarves. Let's say we've got, let's see, right, 2 patterns that represent that. Scarves cost 1.5. Okay, well, hats, let's say, we'll just count by ones. 1, 2, 3, 4, and 5. Okay, we'll say hats are $1 each, so we're just adding $1 as we go down the line. Scarves cost 1.5 times as much. So what we are going to do is we're going to multiply my number of hats by 1.5 to get my number of scarves. So 1 times 1.5 should give me, well, 1.5. 2 times 1.5 gives me 3. 3 times 1.5 gives me 4.5. And we're just going to follow this little pattern. Then explain how to find the cost of 6 hats and scarves using the pattern we wrote. Well, hats are counting by 1. So I will add 1 to 6. Or sorry, I will add 1 to 5 to get 6. That's just part 1 of my explanation. Part 2 of my explanation is scarves are counting by 1.5. So I will add 1.5 to 7.5 to get 9. That would be my explanation, and here is my work, proving that I know what I am counting by for each section. That's it for the first 2 pages. On to the next section, where we really start looking at what makes a ratio. In case you do not remember, a ratio is a comparison of 2 or more amounts. I know I misspelled comparison. I'm in a rush. So, for this, it's talking about a florist making bouquets, and it gives us, right down here, something important. It gives us 3 different ways that we can write a ratio. One way as a fraction, one using a colon, and one using the word to. It says, write the ratio of carnations to daffodils in 3 different ways. So carnations to daffodils, we have 1, 2, 3, 4, 5 carnations to 3 daffodils. Option 1, that would be 5 to 3 as a fraction. We also have a colon form, 5 to 3, and we have word form, 5 to 3. Number 2, it asks what is the ratio of the total number of flowers to carnations. Okay, let's count the total. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 12 total. And carnations, we have 5. So there's colon form. So 12 to 5. Word form, 12 to 5. Fraction form. Number 3, describe a ratio in words about the flowers that compares one part of the bouquet to another part. Okay, let's compare roses to daffodils. The ratio of roses to daffodils is, that would be 4 roses to 3 daffodils. And then down below, the ratio of, we'll do roses to carnations is 4 to 5. There we go. Now, you could have also done daffodils to carnations, daffodils to roses. You could have gone out of order here, but as long as you wrote it somewhat in this format, you're okay. Moving along, Ben has a collection of 15 coins in quarters and dimes. There are 7 quarters in his collection. Well, I think you can use a little bit of inferencing here. We've got 15 total, 7 of them are quarters. That is going to leave us with 8 dimes. Quarters total. Okay? Write a ratio for quarters to dimes in at least 2 different ways. Okay? We've got 7 quarters to 8 dimes, or we have 7 quarters to 8 dimes. Write the ratio of dimes to total in at least 2 ways. Okay, so we've got 8 dimes, 15 total. So 8 to 15 and 8 to 15. Describe a ratio in words about the coins that compares the whole coin collection to one part. Okay, so we'll say there are 15 total coins for, we'll say, 8 dimes. And then it wants us to write that ratio in 2 different ways. 15 to 8 and 15 to 8. For number 7, the ratio of quarters to dimes the same as the ratio of dimes to quarters? Or is the ratio of quarters to dimes the same as dimes to quarters? Well, no. It's in a different order. Plus, the fraction forms are not equal. Show you what I mean. If I have dimes to quarters, if you remember, we have 8 dimes to 7 quarters. But then if I say quarters to dimes, I have 7 quarters and 8 dimes. Those are not the same. Those are not the same fraction. Therefore, it's not the same ratio. That's how you can tell if a ratio is the same, is if their fully simplified fraction is the same thing. And frankly, 7 over 8 and 8 over 7 are not the same. For this next one, they have a plate of apple slices and orange slices. The ratio of apple slices to the total number of slices is 4 to 11. The ratio of the total number of slices to orange slices is 13 to 6. Neither person has more than 20 total slices. Who has more orange slices? Well, since it says neither person has more than 20, I mean, 4 to 11 and 13 to 6, that's already like just about 20. So this person, we'll just go ahead and add those two amounts and say they have 15. And for Pam, we'll go ahead and say that we'll add those together and get 19. Who has more orange slices? Pam does. First of all, she has a larger ratio. But also, since 13 to 6 is already closer to 20, and it can't go over, then she must have the most. Bottom line, the answer is going to be Pam. Now this last page, I want you to do on your own. This will be its own little section following up on Canvas page. Feel free to rewatch this video again and see if there was something that you had missed.